Hello, everyone, and welcome to another Tuesday of Zephyr webinar. What I was explaining on the previous sessions, we already uh, write our binding file, which basically describe a few properties. The most important ones, it's a fundal array that specify the GPIOs, the GPIO array. We later on use these same properties in order to declare, declare, describe, whenever you want to call it, an LED that is connected to our board. In my case, I'm using an MSTN32 board with an LED connected to pin 0 from the port C, as you can see right here. Okay. With this note in my device tree, I can go to the main.c, extract the information about the port and pin using this specific macro. All right. Later on, use it to configure the pin in order to work as an output, and then use it to toggle the LED every second. All right. So you can see right here that I'm using the functions provided by Zephyr to controls the GPIO pin, which is part of the HAL drivers that already comes with Zephyr. Those are standard functions that no matter the microcontroller you're using, it's always be the same. So in this webinar, in this second part, we are going to create our own functions. Remember that we are manipulating LEDs, so we are writing a driver specifically to handle LEDs. So we don't want to use a GPIO underscore pin underscore configure functions. We want to use something like LED underscore init, and then another function, call it LED underscore toggle. All right. So let's do the following thing. Let's create a new files right inside the src directory. The first ones I'm going to call, sorry, I'm going to use the same name that I'm using, simple LEDs, and that's because this is the name of my driver. Okay, I'm gonna create a header file first. So, and in here, we're gonna place some C preprocessor functions. And okay, and I'm gonna declare a very basic functions. All right, a simple LED init, and this function is gonna set a parameter, constant stroke, an LED. So I'm not gonna specify the number of LED. All right. So I'm gonna need to use one functions per LED, but that's not a problem. We want to make it as simple as possible, right? So this is important. We need to pass a GPIO DT spec, right? So the second functions that I intended to write, I'm gonna get advantage of my AI assistant tool, right? So it's of course, the toggle functions, all right? Nothing to return, but a parameter to accept, which is the LED that we are configuring in our device tree, all right? This is very important since we are going to use the GPIO low-level drivers, we need to include it as well. So we're gonna create another file, the complement of this one, where we are going to define both functions, right? So let's go for a simple LEDs.c. So we are going to copy and paste the functions that we just have in here. Don't forget to include our header file. And what we're gonna do in here is very, very, very simple. You know, we're gonna call the low-level functions that we used to call it right in here, and we want to call it right here. Okay, so I don't trust really well on the AI assistant, so I'm gonna make sure that I'm doing that I'm writing the correct functions, all right? So the same for toggle LED, all right? So we are gonna call these functions inside the functions that I'm prepared for my driver, right? So I'm gonna save it. And what I'm going to do is very simple. I'm gonna go to the main, right? So, and I'm going to include my new header, and I'm going to replace these functions for the newly created functions, all right? So notice that the only advantage that we have is that we are hiding the fact that we are using a low-level driver, all right? But that's the only thing that we are doing. We still need to use the same macro, and we still need to extract this property from the device tree. Remember, which one is this property that we are extracting? Well, it's basically this one, meaning that we are extracting the information about the port, the pin, and the flag that is assigned to this property and specifically to this child node, right? So this is something very, very simple. And the way that we are creating these files is a regular one. I mean, just forget that we're using Zephyr. Let's figure it out that we are doing a driver for a bare metal project or something based on FreeRTOS. This is the classic way to create a driver in C, right? A .c file, a header file, when you declare the prototypes, then later on you include on your application and you start using your functions, okay? Very important thing, since we are making a new file that needs to be compiled, we need to specify in our CMake that this file exists. It's actually is there, all right? Once we have everything in place, let's proceed to build again. As we're gonna see that it's going to work. It's going to be built with no problems at all. So what's the benefit of doing this? Well, nothing. What we really want is to create something the Zephyr way, okay? A driver in the Zephyr way, which is the specifier in the driver model for Zephyr, all right? So let's go step by step. Let's proceed with baby step, all right? The first thing we need to do is to create on a root project, on a root folder, a new folder that we're gonna call it drivers, right? The name is very important. And inside this driver, we're gonna create a new folder that we're gonna give the same name of our driver, okay? So we're gonna move these files that control the LED functionality to the new folder that we just made, okay? And like I was mentioned, the driver folders needs to be named like that because we are actually replicating the Zephyr structure. If we take a look on the Zephyr official repository, we can see right here, I have it in Zephyr, okay? There is another directory called driver. And inside these folders, we can find a huge variety of drivers that already comes with the Zephyr upstreams. Like for instance, the ADC, okay? Very different version of the ADC files, depends on the microcontroller or an external peripherals that we are using. The same with the driver of the audio, auxiliary display, Bluetooth, and along, etc. So we are just replicating the same folder structure in our local project. So that's very important. The folders needs to be called drivers. Then later on, the folders that you made, it will correspond to the name of your own driver. Has nothing to do with the name of the files, but it is good to make the match, you know? Okay, so we can try to compile again our projects and we're gonna see that it's going to fail. Let's do this so you can see it's failing, right? So why is failing? This is basically because CMakes couldn't find the new this files that needs to be compiled. You remember in CMakes we are specifying a very different route. Okay, we can change it, of course. Now it's located in drives slash simple LEDs. All right. Also, we need to specify where the header files can be found. So for that, we're gonna use a built-in CMake functions called target underscore include underscore directories. Okay. Watch out with the typos. I don't trust on AI, sorry. And I'm gonna use this private, but it's not in this directory, it's in this directory, right? So now on CMake, I'm telling this, okay, there is header files that you need to look on this directory right here that belongs to this project. And also I modify the location of the source files that need to be compiled, right? Let me check again that I don't have any typo. And if I don't have any typo, I can build again from scratch and verify that everything is working as expected. No, it's not as working as expected. Let me see where was the problem. It's target include directories, target includes directories. The folder is called simple LEDs, drives. Okay, yeah, here is the problem, it's drivers. Yeah, that's the problem when you're starting to write code on an online session. So let's build again, and we'll see there is no problems at all. All right. Okay, cool. We didn't modify anything. We just modifying the location of our driver, and that's it to comply what we said with the Zephyr folder structure. But we are far from making a driver on the Zephyr way. So let's do the following thing, because on Zephyr, when you use a driver, you don't need to add header directories, neither source files in this specific way. It's something more automated. And in order to emulate that, we're going to create a new file, a new CMake file, that we're gonna use to build our driver. It needs to be named in the same way. So let me tell you something, Zephyr loves CMake and Zephyr loves CMake leads file. So what we're gonna write in here is we're gonna use some built-in Zephyr CMake functions that already comes with the Zephyr distributions. All right. So the first one is to indicate where the header files are located. The second one, as you may guessing, is to indicate where the source files that need to be compiled are located and which one are these source files, right? Which one was simple, it's .c, all right? So basically what we just did right here is it is what we have in the main project CMake file. So I'm going to remove this because I'm no longer needed, and I'm also going to remove also this because I'm no longer needed. It's been already specified in here using these built-in CMake functions defined by Zephyr. Okay, this is important. These are the functions that these are CMake functions that comes with the Zephyr projects. It does not ship with the standard with your standard CMake distribution. Okay. So in order for Zephyr to recognize these new files, we need to create a new folder that we're going to call it Zephyr. The name is very important. And inside these folders, we are going to create a new file, a new YAML file. Call it module.yaml. Where are we going to write the following directives. Name, we're going to give it names. We're going to use the same name that we are going to use it. And we're going to specify the build. Where can you find a build? The build is CMake, as you can watch it right here. And where it is located? On our same directory, the same directory that is located the Zephyr folder, all right? Not on the directory, not on the current directory where is located this file, but where is located the Zephyr folder, which in turn is located the cmeglist.txt, the source files, and the header files for my driver, okay? This is important, okay? One last step in our main Zephyr directory. We need to indicate it, or we need to set the variable Zephyr extra modules with a new value. All right. And this new value is basically the CMake current source directory. Is the CMake source dir, not current. Okay. That's what sometimes I don't like the AI. And drivers, yeah, okay, but which drivers? Simple LEDs. Okay. Since we're using one single driver, we need to specify which driver are we using. If we have more than one driver, we can create another CMake files exclusively for the folders drivers, but we are not going to do that because we're trying to keep things as simple as possible. All right. So we are setting this variable, this Zephyr global variables, with the let's say the location with the path of our new driver. So we're going to try to build again and again from scratch. Let's catch the potential errors that I potentially made. Or let's verify that it's working as expected. Good, good. That's perfect. That's really what we want. Okay. We don't want to specify the header and the source file in our CMake. We want to specify there is some extra modules on this location, right? So the specific CMake file for this driver is going to be in charge of telling, yeah, here is the header file, and this is the source files that you need to compile, all right? But it's not over, okay? Right now, it's working as expected, it's being built as expected, but what happened if I don't want to use it anymore, right? What happened if I just don't want to use it, this driver? So it is as simple as to remove the functions that I'm using, but the driver will still be part of the build, because essentially what we need to do in order to get rid of completely of the driver is to remove this line. But I don't want to do that, all right? Because this is not what you do when you use the drivers that already comes with Zephyr. So you don't write the location of the drivers on your CMake, and you don't remove this a similar line like this one on your CMake every time you don't want a driver, right? That's not what you do, right? You usually do something more, let's say more fancy. You basically do to write a directive in your key config file. In my case, is called prj.conf, which is the key conf file that I'm using for my project. And you usually write something like this. In our case, simple LEDs, right? You write N, you don't want to use it, or you write Y if you want to include this driver as part of your build. And that's what we want to do. That's how we want to control when we want to use our driver or not. Right now, it is not possible to do it in these ways. We need to do something else. We need to add the specific file with the specific instructions in order to automatically our build compile or not driver. How we can do this? How are we gonna do this? Well, it's relatively easy. We just need to create again a new file as part of our driver, and we're gonna call it capital K. I'm gonna call it kconfig, right? So what we want to write in this kconfig is very simple. We are going to define basically this, what we are doing right here. No, I don't want to use AI. And the first things that you're gonna notice is we are going to write like this, simple underscore LEDs. And the word config is going to be add as an instruction, right? It's part of the key config description language, right? It's not part of the name. The name is simple underscore LED. And what we're gonna do in here, we're gonna specify what kind of value are you going to set. Well, it's gonna be a bool. If we want to write, we can assign a description of this value. I can write something like LED handler functions or some sort of. I'm not really good to make comments, neither descriptions, right? The second ones, we can assign a default value. I mean, a value of n. So what represents this is basically this. If you do not define config underscore simple underscore LEDs with a value, by default, it's gonna assign it this value n. So it won't be included in our build. So if we want to use a driver, we will need to specify the value of y. Okay, and let's go back. It's going to be the default value. By the way, do you want to add a comment? You can use the symbols and you can start writing a value. A comment by default is not set. Okay, good. The following directed since our simple underscore LEDs drivers depends on another low-level driver. It's very important to specify this. And so we're gonna use the instructions depends on the driver GPIO. Meaning if the GPIO doesn't exist, the build has to throw an error triggered by the key config, telling you you are trying to use a driver that in turns use another ones. Well, guess what? It doesn't exist or is not being enabled. All right. So this is something very, very useful, right? So in theory, in order to use this directive, you should have the low level one. You should enable the GPIOs. All right. So we are using by default the Nucleo board definition that comes with Zephyr, and by default the GPIOs are enabled. So in theory, we do not need to enable in key config the GPIOs. All right. It's being enabled by default by our board defining in our Zephyr, but that's fine. We're gonna specify. All right. So another very important thing that you need to do is to go back to the CMake corresponding to your driver and doing the following thing. Basically, what you're gonna do is to let you know. Build only its simple LEDs is defined in the key config, right? If this symbol exists, right? Come on, I want to use tab. All right, so let's make it beautiful. All right, so what else? What else need to do? Is it ready or not? Well, it's not. We need to go to our model YAML and we need to add an extra thing. This is going to be the last one, I promise. Config key config. you're basically telling the name of the file, of the key config file that you're gonna use. This is just a name. I mean, usually you're gonna find a lot of key config files on the Zephyr distributions, and some of them are named after key config, maybe some a period, and maybe they specified uh, another name. Okay, in our case, we are only have one simple drivers and want to make it things as simple as possible, so that's what we only going to use a key config name, the one that we have right here. This is important. I'm gonna save. I'm gonna take a look at what I've done so far. This is my driver, and we make a specific folder for the driver named simple underscore LEDs, the Zephyr folder to help CMake to locate the files to compile. I'm sorry, the CMake is going to be used to build this driver, a model YAMLs where it specify where it's going to find the CMake leads file, the key config and its name, and the CMake for this folder, the key config defined for this specific driver, and of course, the source and the header file for the driver, right? So simple leads are enabled. Let's try to build again, and let's catch some potential errors. And if not, we are going to see everything is working as expected. All right, let me close all the files that I just opened. And let it close it like this. Then okay. Now I have my simple underscore LED drivers ready to be used using the proper functions that hide the fact that I'm using a low level layer that is the GPIOs. Let's try to tell our drivers that we don't want to use the simple underscore LEDs. Yeah, it's going to fail. It's going to tell you, well, I just can't find these header files that you are telling me to use in this line, right? Why? Because the CMake, where it's telling you where to find the header files, is not being taken into account, okay? Do this if these instructions are not being taken into account by the main CMake files, by the build systems. So let's go back to here and let's try to do something. Let's try to tell I'm not using the GPIO. The GPIOs are not enabled. Well, let's see what's going on. Let's see if this works. All right, again, GPIOs are not there. I don't know what you're talking about it. Why? Because in our key config, we are telling that in order to define simple LEDs, it depends on the GPIO. GPIOs should be enabled. Otherwise, I won't be able to enable simple underscore LEDs. Let's enable both again, and let's verify the driver is working as suspected. Are we done with our driver? No, not at all. Not at all. There is still some work to do. For instance, what we're doing on our device tree is basically describing an LED, all right? So what we want to do is to extract a device that represents an LED. We should have something like this, right? Yeah, something like this instead of something like this. I don't want to extract the port pin or the structures where the port pin and the flags of the pin because I'm not interested on a pin, right? I'm interested on an LED. So what I want is to extract something that describes the LED that later on use with my boards, with the rest of the functions in my driver. Well, that's precisely what we're gonna do on the following part. Okay, I'll see you in 2 weeks where we're gonna instruct Zephyr that the initialization functions will no longer being carried out manually in code by these functions, but is going to be initialized by the same Zephyr operating systems. And we need to do some magic in that. We need to extract some information from the device trees. We need to modify the functions that we have in defining in here a little bit, and we're gonna get the advantage of the Zephyr driver models, right? But for the moment, it's more than fine. Now that we know how to put it on a specific directory or files, and I had to add the proper files that gonna tell the build systems where to find and how to compile the drivers. Okay. Next on the next sections, we're gonna tell Zephyr how we gonna how we gonna build this, how we gonna initialize the drivers using the proper functions. And we're gonna add some extra functions that will allow us to verify if our driver is being initialized correctly, such as validating the parameters that we pass on the device tree and so on. So my name is Diego. This was another Zephyr webinar. Hope you like it. And I'll see you on the next section. By the way, if you don't want to go through the webinar again, you can go to Embedded House, which is our webpage, where you can find all the instructions that I just showed you written. You can follow in the step and you can create your first driver. All right. So then again, see you in 15 days, in 2 weeks.